All right, here's the part two video of the sum difference. So this is kind of where we can get information about one angle. So we know that the sine of alpha is -3/5 in quadrant 3. So sometimes I'll be hey, it's in quadrant 3. Tangent of beta, so different angle, is -7/24. And they tell us that beta is between 3π/2 and 2π. Okay, we got to get really strong with our radians and just go back and forth. That's 270 and 360. So, degrees, if you change it to degrees, if you want to see it better, that's quadrant 4. So we'll make a little note to ourselves. Quadrant 4. So this guy's in quadrant 3 and this guy's in quadrant 4. Well, they want to know alpha minus beta. Well, I don't know what angle this is. I could find it. It'd take some work with my calculator and find this ugly angle and find this ugly angle, then subtract them and then take the sine of it and stuff. But we're going to actually find an exact value for it by using our formulas. So the first thing I need to do is as we learned in class before we left, if you guys know one trig function, you know them all. Because remember, when I'm giving you one trig function, I'm giving you two sides of a right triangle. If I give you two sides of a right triangle, you can find the third Pythagorean theorem. And that means I have all the sides, so I can find any trig function. Especially when they tell you what quadrant. So the best thing to do, draw a triangle in quadrant 3, because they said sine is 3/5. Remember, sine is opposite over hypotenuse. Now we can we're going to use this angle right here. That's our reference angle, if you guys remember the definition. Particularly alpha was from here to there, but we just it's the same as that value there, so we just use the reference angle. The third side is 4 by Pythagorean theorem. Now, how about the signs? Well, we're in quadrant 3, so left is negative, down is negative. So some people like to put in the signs, some people don't. If you don't put them on here. But 4 is negative and 3 is negative, so those would be negative. That's where we get the -3/5 from, for those people that like to do that. But I could just remember what quadrant I'm in and use the quadrant system. So I prefer using this all the time, but again, the signs might help some of you. Now, we are not going to be using these at all because we don't know. These angles are ugly angles. We don't know what they are. All right, so the first thing, the key to doing this whole section is write out the formula. That's my opinion. Is I write out the formula. All right, sine alpha, cosine beta. Remember, if it was minus, it stayed minus. The sine formula does that. Cosine alpha, sine beta. So now I just got to find these. I forgot to do my triangle over here. My fault. I'll do that right now. Over here, let's do this one. We'll call the alpha triangle, and this one we'll call the beta triangle. All right, technically the angles this way, or it could be that way. And then we got tangent 7/24. Third side, it's actually one year triple, 7, 24, 25. So that third side is 25. All right, who gets the negative sign? Well, if I went right, 24, and then 7. We knew there had to be one negative sign because it was a negative value there. All right, so there's your two triangles. Now I can use those. Instead of using these triangles, which are known values that are always true, these are for this problem. So now it's almost the same thing. What's sine of alpha? -3/5. I didn't need the triangle, I already had that. Cosine of beta. See, they gave me tangent, which I'm not even going to use. Cosine of beta, 24/25. Cosine of alpha. Go to alpha. Cosine of alpha is -4/5. And sine of beta is -7/25. All right, I could multiply these together. I got -72/125 minus, and I got a negative times negative, so positive 28/125. And I get -100. Whoops. So I got -72 minus 28, so there's -100/125, which actually reduces to -4/5. All right. So that's sine of alpha. Sometimes it doesn't clean up that nice and reduce that nice, but hey, that's what it turns out to be. Okay? All right, so in your calculator, if you had did arc sine of -3/5, found alpha, and make sure you're referencing, you did it in quadrant 3, found out that angle, and did arc tangent and found angle B, subtracted those, and then punched in sine, you get -0.8/4. Okay? All right, let's try another one. Let me erase this. We just use the same information, and let's do cosine of alpha plus beta. So, well, that formula is cosine alpha, cosine beta, minus, remember cosine is the opposite, sine alpha, sine beta. So I just remember the cosine formulas are cosine, cosine, sine, sine. All right, so cosine alpha, so my alpha cosine is -4/5. Cosine beta is 24/25. Minus sine of alpha, which is -3/5. And sine of beta, which is -7/25. You're going to know, sine's opposite over hypotenuse, cosine's adjacent over, I mean, you have to just, that's got to be just like, tying your shoe. And tangent's opposite or adjacent, we should know those values. All right, so when I multiply here, I get again negative and a couple negatives there. All right, so I end up with -96 minus 21, so -127. No, -117. That's bad math. Over 125. And that doesn't reduce. The gap is 8 here, and nothing in the multiple of 8 goes into the 125. That's it. So you can see how sometimes they are going to be more of a bigger fraction. All right, so that's cosine of alpha plus beta. All right. All right, let's do a tangent. So on the other video, I think I did a plus, so let's do a minus. The formula for tangent. So you can look at your sheet. I write down the formula first. Is tangent of alpha minus tangent of beta, because it's the same, but then this one switches plus. And remember, this is times, so we're gonna have to. This is where they'll do this right, and then their math they'll be frustrated because they don't get the math right. With today's calculator, I mean, you just use your fraction button, type it in, and it'll take care of it for you. But we should learn how to do it. Tangent of alpha, okay, tangent of alpha is 3/4. Now you notice I have a positive value here because we are in quadrant 3, and tangent is positive in quadrant 3. All right, minus tangent of beta. Well, tangent of beta is what they gave me, or I could look here. And then same two values, so I don't have to redo them. I know it's 3/4 and -7/24. But they're multiplying, tangent of alpha, tangent of beta. All right, this is just ugliness. So there's some tricks to clean this up quickly. I'll show that trick to you. But first off, let me clean up what I have before I show you the trick to cleaning it up. All right, so this is 3/4 plus 7/24. All right, I get a common denominator, combine those if I'd like. Some people will teach that way, which is nothing wrong with that. All right, so let me kind of explain this. I just rewrote this. I got a plus sign because minus. And it says plus here, and I wrote minus, but you notice that I have a -7 times 3, so I got a -21. And 4 times 24 is 96. You notice I multiplied those together. I didn't add them, okay? All right, now, what we kind of learned in Algebra 1 back in the day was you get a common denominator here, you got a fraction over fraction, then you flip over the bottom, divide by, and clean it up. Then you got further along, and you guys got to Algebra 2, which are IM3. Then you learn some tricks on how to clean up these fractions. So what we're going to do, if you look at all your denominators, we're going to multiply everything by the common denominator. Now, if that's hard for you, then maybe you want to just add them together. But common denominator of 4, 24, and 96 is 96. So if I multiply every single term, the whole top by 96 and the whole bottom by 96, this will clean up really nice, okay? So if I multiply 96, this 4 goes to 96 24 times. Times 3, I get 72. And then I get 28 here. The 24 goes to 96 4 times. 4 times 7 is 28. And then on the bottom, I get 96 minus 21. 96 times 1, the 96 cancels 21. And you can see how it's down to one fraction immediately. Saves you some steps. So again, I have 100 over 75, which is 4/3. Okay? Now, let's go back. We did we do sine of, I think it was sine of alpha minus beta first. Right? And if we remember right, we got 4/5. But we got a negative 4/5. So that means we're not in quadrant 1. And it's sine. So we must be, if it was negative 4/5, then we're either in quadrant 3 or 4. Well, we just did tangent of this alpha minus beta and got 4/3. So if you did Pythagorean theorem, you can see that tangent would be 4/3. All right. So maybe I did cosine, I don't remember, but it's kind of the same idea. If you get the idea, oh, well, actually, no, it would have been sine. Once you do one trig function, you can do them all. So, for example, I do sine of alpha minus beta. I now know the two sides of that triangle. I can use Pythagorean theorem and then find the third side. Okay? So I showed you one of each. That's kind of what we can use sum and difference angles for, is to find those little middle ones. And if we have information of angles, we can add them up. Okay? All right, there you go.